Another session here at Electrical Code Academy. My name is Paul Abernathy, the host tonight, and we're going to be doing some exam prep tonight. We're going to be looking at some questions and dissecting some questions. We've got our electronic code book handy. We've got some code questions handy. So we're going to be digging in that tonight. So if you're preparing for an electrical exam, then you want to grab your code book. Now we're going to be using the 2023 edition of the National Electrical Code. So, but that doesn't mean you can't follow along, even if you're in the 2020 edition. It doesn't really matter because, or even the 2017, because again, code is code. Some of the sections might change a little bit or something like that. But again, nothing that should give you any excuse not to grab that code book, and let's start studying a little bit tonight. All right. So let's go on and get to the first question here. So the very first question that we see on the screen, let's kind of work it out. And I've got it blown up over here so I can read a little bit better. It says conduit or raceways, including their end fittings, shall not rise more than blank inches above the bottom of an enclosure. So as these raceways or conduits come in underneath an enclosure, and typically this would be like, let's say, an open bottom enclosure, and so they come up through the bottom, then you've got some limitations you have to be aware of. Now, first thing we're talking about is we know that this sounds very much like a switchgear or something very similar to that that's coming in, or a switchboard or something that's coming in the bottom of it. Now, you could probably go trying to run through conduit. You could probably try to go and run through all types of areas in a code, but you're going to have to get familiar with looking at the question and say, okay, this is literally talking about coming up in the bottom of panel board or switchboard or switchgear or something like that. So all of those are in 408. So you're thinking, okay, well, we could use our index. And of course, as we know, Link does not have an index option. So I will be using the index, and I grabbed my code book. Now, this is the 2020 because I realized that a lot of people would be following me on the 2023, and that's going to be what we have in Link. But then I also want to be able to cater to those that are in the 2020. So we try to cover all bases here. So, all right, so where will we go? Okay, so in this case right here, let's go on over to look at the code. So here we are in the code book, and I'm going to go down to 408. Because that is switchboards, switchgears, and panel boards. And this sounds like raceways coming in. Obviously, it was a cabinet, wouldn't be the case. Okay, so let's see here. So we'll bold scan. So that's the scope. Reconditioned. Support and arrangement of bus bars, not what we're looking for. Okay. Descriptions required. That's circuit directory labeling. And clearance. Okay, clearances for conductors entering bus enclosures. Okay, so it says where conduits or other raceways enter a switchboard, switchgear, floor standing panel board, or similar enclosure at the bottom, approved space shall be provided to permit the installation of conductors in the enclosure. Okay, it says the wiring space shall not be less than shown in table 408.5, where the conduit or raceway enter or leave the enclosure below the bus bar. That allows me to have space between where it enters and the bus bar, right? You have to have that bending space and all that kind of stuff, clearances. All right. Now, it goes on to say, and one thing that I always tell students to be very aware of, right? If you go back and look at the question, we're given values here that are in inches. 3, 5, 6, and 12. Okay. Now, again, it's not always the most intuitive thing in the world, right? You don't always look at a question and say, well, this question needs to have more information. Well, sometimes this is it. This is all you get. So you have to use a little bit of your knowledge and realize, oh, wait a minute, this is talking about coming in the bottom of an enclosure. So it could be either a panel board, switchboard, switchgear, but it's coming in the bottom, right? Obviously, if it was a box in 314, then it would be securing it to the box. So this kind of tells you when you read it and go, wait a minute, this is coming in the bottom. It doesn't say open bottom here, but it is talking about coming in the bottom of an enclosure. So I don't want you to go running over to 314 on this. This one here, I'm thinking, well, the index is probably not going to be helpful, but you're looking at it, you're going, okay, well, it sounds to me like this is a panel board, switchboard, switchgear, something like that coming in the bottom. And that's the best way to answer a question like this. Okay, so let's go back here. And of course, you see right here, it's almost written verbatim. It says, a conduit or raceway, including their end fittings, shall not rise more than 3 inches above the bottom of the enclosure. Okay, so that's your answer. So let's go back here to the question. And right here, and oh, and by the way, these are the questions that are in our 2023 Fast Tracks program, okay, in case anybody wondered. These are the ones that are in there. All right, so we'll go with 3, and there's our code reference, 408. So very good, we got that one right. So we can go on to the next one. All right, let's look at this question. And this question says, surface-mounted incandescent luminaires, okay, may be installed in a closet and closet on the wall above the door or on the ceiling, provided there is a minimum clearance of blank inches between the luminaire, okay, and the nearest point of the storage space. So you remember in a closet, you've got a certain amount of storage space, right? And then you got shelving space, and you have a different dimension for that shelving space, either the dimension of the shelf or a minimum of 12 inches. But where do we go to find all this stuff? Now, the first thing that you would dissect about this is it obviously deals with luminaires. Now, if you were one of our students that went to their flashcards, you probably have already made a flashcard by now that was labeled luminaires, and you probably called it Article 410. So hopefully if you've done that, then you already know that the thing about this is everything here is talking about luminaires. Now, could you have gone into your index on this one? Sure, I could probably go into, look under closed closets. That might be a word we dissect, and that's what you really should do when you're in that practice phase, right? So let's bring this back to me. Let me explain something real quick. When you're studying for an electrical exam, don't be in such a hurry to answer every question. I know that everybody will tell you that preparing for an exam, you need to get a good set of questions and you need to time yourself. No, you pay good money for questions. What you want to do is use them to the best benefit, and that is to dissect them, look at all of the root terminology, see if where you might be able to find this answer, either you know it or you would use the index to help find it, because the index isn't perfect, right? It's not the holy grail. It's pretty good. It's not like a Tom Henry keyword index, okay? But it is pretty good. So if I were to go to the index, okay, and you can do it too. And oh, by the way, soon we'll be adding an additional camera, as you can see here, that'll be up here so that we can shine down on our code book. I've got the cameras. I've just been too lazy adding it. All right, so let me go here real quick. So the first thing you could look under, let's just go for craps and giggles. Since we're talking about a closed closet, let's go to closed closet and just see what it would be in the index. If you got your code book, go with me. See what you find. So I'm going to go look, see if there's anything under closed closets. Just to see, because that is a terminology that's used. We have closed dryer, closed closets. What do you know? So there is something in closed closets, and it happens to say luminaires 410.16. Okay. All right, so obviously that didn't take us any time if you want to use it. Now, I'm curious, just because we're learning, right? What about if I didn't go to clothes closet, which is the subject? What if I had gone to luminaires? All right, well, let's go look at luminaires real quick. You got your code book. Let's go look at luminaires, and let's see what we might have under luminaires. See if it says something about clothes closets. So I'm going to go look, luminaires, and sure enough, it says clothes closets, 410.16. Of course, if you're a fast track student, you also know that Article 410 was luminaires, and you could have used what we call bold scanning. And that is where you look at the headings or each one of the articles, boom, boom, boom. And what you're doing is looking for relevance that's in the question. That's what you're really scanning it for, okay? See relevance and things like that, okay? So there you go. Hey, David, CMECP joining us from over at Facebook. Good job, David. It's definitely in 410. So I'm in many ways to find it in the index. But a lot of times, if you're kind of familiar, and if you go through the Fast Tracks program, you'll probably already know this answer anyway, right? But you have to kind of go through the process, okay? All right, so what's what we're going to do? We're going to go to 410.16, see if we can answer this question. So let's get over here, and I will get to us, and we will get over to the lesson. And here we go. All right, so we're going to go to 410.16, answer this question, because we have pretty confident at this point that's where we got to be. Okay, so when you're looking at a question, realize it gave you answers in here, right? And obviously the answer was in inches. So when you see these are like feet, things like that, and you see all these things, you see 24 wasn't an option, and you see, so it allows you. So here is basically, A is just describing this area in a closet, okay? These are the prohibited areas, okay? So you got these little zones, 24 inches wide. You got at the shelf level, it's 12 feet all the way around, except for if the shelf is wider than 12 inches. If the shelf is wider than 12 inches, then you go with the width of the shelf, right? For us, most of the time, you realize that the shelf's not there, right? When we're roughing it in maybe or something like that. So you got to be careful and know those things, obviously. But we're just trying to learn the code to prepare for an electrical exam. I do have some great news to announce to people that I probably should announce for those that follow me. Coming up in 2024, we have a new studio that's opening up, and we're going to do a lot of hands-on. Okay, so I'm going to show you a lot of stuff out in the lab. I'm going to show you drilling. I'm going to show you wiring up circuits. I'm going to show you the proper way to run products and all that kind of stuff. I'm excited about that. We're working on that now. So hopefully by about February of 2024, that'll be completed. And we'll have a lot more videos with some hands-on stuff to share with you. So a lot of people are excited about that. Okay. And again, maybe it's stuff that already is on the internet, but as always, I'll do it with a different flavor, I promise. Okay, let's get back to the... So there we are in the code. So that just gives us the dimensions, all right? So now we're going to go down and we're talking about locations, right? Because again, the question was about a surface-mounted incandescent luminaire and where could we place it? All right, so let's see here. Here's a surface-mounted incandescent luminaire, okay? And then, of course, we have a surface-mounted fluorescent. Then we have a recessed incandescent. And then we had a recessed fluorescent, right? But the question was about a surface-mounted incandescent. That's what the question was about, right? So Alberto said 6 inches. Well, I think we got to go back to the lesson. And I think that we're going to see that the answer is 12 inches, 410.16D, okay? So remember, we have to be very focused. This question was about the location of that luminaire. This was a surface-mounted incandescent, not a fluorescent, right? Okay, there you go. Okay. Good information, David. All right, so let's go to another question. All right, next question we have is, let's see here, a thermostatically controlled switching device and combination thermostat and manually controlled switches shall be permitted to serve as both the controllers and the disconnecting means for electric heat appliances, provided they do what? Cannot turn off automatically when in the off position, are marked with the off position, open all ungrounded conductors when in the off position, or all of the above. Okay, very much could come up on an exam. Also, I will remind y'all guys, do look at the text in the chat, because again, David's providing a code reference to another allowance about overcurrent devices located in closed closets. Not going to happen. So many people say the panel board is not allowed in closed closets. It's actually the overcurrent devices, but I digress. All right, so you see this question on the screen. What do you think it is? All right, and let's see if I can, I don't know that I can make this even any bigger, but I will see if that makes it a little bigger. That's a little bigger. Okay, well, hopefully it'll give us the code references and not cut it off, but we'll see how it does for us. All right, so what do you think the answer to this is? Well, first of all, we got to realize what we're dealing with, folks. And in this one, it's pretty easy. Why? Because it's stated in the question, electric heat appliances. So what article deals with electric heat appliances or fixed heating appliances or fixed heating? What do you think it is? Well, if you're familiar with the program, we go into it, then this is going to be what? It's going to be Article 424. However, we want to go and see, maybe we can use the index here. So basically, I'm going to look back in the index, and let's go and let's see here. Let's see if I want to look under the index again. So if I'm looking for a keyword here, let's go heating appliances. So I'm going to look under heating and see what we have. Heating appliances. Heating appliances, okay. I get that. I get where it says heating appliances. But we're talking more specific about like a fixed heating. So let's see here. So that might send us somewhere. But where else do I want to go? So I don't see really anything in there that I want too bad, because it does say heating appliances, but I don't want to go to infrared lamps and water heaters and all this kind of thing. So I'm not going to go to 422. It's kind of not what I want. All right. So I'm going to see, I know it is basically fixed heating. So you got to kind of know that. Again, the index is not the holy grail, folks. I wish it was. I wish it made it easy for everybody to just go in there and use it, but it's not. So let's see here. I'm just trying to see here if you got your code book. So we have fixed electric heating equipment. And then we got, let's see, what else do we have? Fixed electric space heating equipment. Okay. This is about heating a space. So it's more applicable to fixed space heating, okay, than any specific appliance, right? It's talking about how to control this fixed space heating. So 424, but if you look at an index, fixed space heating, let's see here, let's look around it. I've got some references that we want to have. Then look at the question again. Okay, controllers, disconnecting means, what is it asking about? Thermostatic controller. So I'm looking down and see what I might have down here that might be beneficial to me. So I'm just kind of scanning it down. You should be doing this too. Okay, I could just give you the answer, but what's the point? You need to scan it down and see where it might be. And let's see here. Okay. Nothing is totally, nothing's jumping out at me. So for me, I'm going to say, okay, so what are we talking about here? So we're talking about thermostatic controlled switching devices. And we're talking about whether or not to serve as the controller or the disconnect. Okay, so let me look under disconnecting means. Okay, that's about as close as that. Controllers. Okay, I got control and protection. I've got controllers. That's in the question, right? So that would be 424.20. That gets me about anywhere, somewhere around it. And then underneath that, you see disconnecting means. That's 422.19 through 424.19 through 424.21. Seems to me that logically that's where we need to be, okay? So now we can start our bold scanning, okay? Again, I think a lot of people wish that the index was perfect, but it's not. So you got to get used to looking at a question, dissecting the pieces. So controller and disconnecting meaning is helpful, but we also got to know that this is talking about fixed type of heating, that type of thing. So all those things kind of go together. So let's go to the index to the code really quickly. And okay, so let's go to 424. Now the good news for those that are in our Fast Tracks program, we go over these things. And so it makes it a little easier to understand the transitions between things. And so again, you have an edge on most people if you've been through a program, because it allows you pretty much to get used to picking out things. And of course, you'll see it repeated over and over through the course. So it just makes it a little easier. So you have an advantage, most certainly. And that's what the whole purpose of a Fast Tracks program is. All right, so here we go. Now, if you were bold scanning, okay, and we're talking about disconnecting and controlling, things like that, thermostatically controlled, that we're looking for those triggers, right? So there's the scope. We said to go to 424.20, but we're just going to look really quickly at bold scanning. So, you know, this has nothing to do with it. This has nothing to do with it. This has nothing to do with it. Okay, installation, general, it's not in the question. Supply conductor's not in the question. Okay, location's not in the question. Space for combustible material, not in the question. Boom. Disconnecting means. Okay, so we're thinking of disconnecting means, and then we go, okay, but let's look a little further and see what it means. Trigger. Thermostatically controlled switching devices. Hello. All right. So what does it say? Serving both the controller and the disconnecting means. Folks, remember the question? Here's the question. Serving as both the controller and the disconnecting means. Okay? So one of the things that I find is very important is when you're looking at something and you think you came to the answer in your code book, you think you got the answer, don't stop. Look a little bit beyond. Okay, because again, you could have different subdivisions and you just want to look around. Don't be in such a hurry. Okay, that type of thing. You got 2 minutes per question. If you work on how you find things, like here, we had to go on to fixed. We would have found disconnecting means or controller or whatnot. Focus. Now, when you're studying for an exam, like I'm telling you right now, do not worry that it takes you 4 or 5 minutes to find the answer, please. Anybody out there that tells you otherwise, or an educator out there that tells you that it's all about speed when you're learning the code, they're full of crap and you should not be following them. They are not there to do you any justice. They're not there to help you, okay? They're there to hold that man card just because they might be able to find it quickly and belittle you into why you're so slow. That's not proper study technique. Our program, we teach you, you want to fundamentally get your money's worth out of the question, for one. Dissect it. Look like we're doing. Look at all the possible ways that you could find these answers. And then when you apply that, it's going to make you a much better person on an exam. For testing purposes and in the field, you're going to be much better. Okay? So just want to make sure that everybody knows that and is on the same page on why we dissect things the way we dissect things, okay? All right, so here's our code, our questions. So now let's get back to the code real quick. All right, so it must be, provided is marked with in the off position, okay? So it's got to be provided it's marked with the off position, all right? Let's see, directly open all ungrounded conductors when manually placed in the off position, okay? So it's got to open everything up, got it. And 3, it's got to be designed so the circuit cannot be energized automatically after the device has been manually placed in the off position. Okay, so let's go back to our question. Okay, so what's the answer here? Can't be turned off automatically when the off position. Perfect. Okay, are marked in the off position. Perfect. Open all ungrounded conductors within the opposite. So all of these are true. So as David said in the comments, all of the above. Absolutely right. We dissected this question. We saw the wording. My biggest takeaway here is, since this is talking about thermostatically controlled and things like that, disconnecting means, then you know that this is fixed electrical equipment. We're not talking about a specific appliance. It's the bigger picture is the fixed electrical space heating. That's the bigger picture here. And of course, the code reference right there, 424.20 A1, A2, and A3 is what gives us all of those. So great job out there for everybody that got that question right. Good job. All right, let's go on to another question. Y'all doing great. All right. So this is a trade knowledge question here. You just got to know this, whether I'm a big fan or not of these devices. And I believe that they have some problems. A Megger or a Megohmmeter is used to measure what? Insulation resistance. Okay, I can't see the screen for me. So insulation resistance, conductance, I don't know what that word is, reactance, or current. What do you think? Well, when you use a Megger, if you use it properly, you're trying to test the integrity of the thermal insulation. Now, granted, you got to have a return path. Okay, so the Meg readings that you get from insulated conductors in a PVC raceway are going to be pretty dicey. Even though you might get some readings you think you're happy about, after you get to about the third conductor, you're going to have capacitance, and now you're going to get some funky readings, and you might get even low readings because this capacitance builds up on the conductor's surface, and then you all of a sudden get a low reading. You think you got a bad conductor. Okay, so again, make sure you discharge everything and don't rely on your Megger. Make sure you touch all of your conductors prior to testing another conductor. Touch them all to ground to make sure you discharge anything and all that kind of stuff. Okay, but not a lesson on that. But hopefully starting next year, I will do some training on that. All right, so what do you think the answer to this is? Obviously, a Megger is designed, and that's a trade name, by the way, to test the integrity of insulation. So that's got to be our answer. Insulation resistance. Reference trade knowledge. Just something you just learn in the field. All right. Doing great. Next question, folks. Get your code books out. If you got your index, if you need it. Okay, what is the next question? It is markings on heating cables. All right, folks. Again, something's going to give us a tip here. But it says markings on heating cables used for pipeline vessels. That's unique. Pipeline vessels, okay, shall be marked with blank of each end of the non-heating lead. Okay, if you don't know the answer to this one and you think, okay, it's heating cables again, this is fixed electric space heating. Nope, nope, stop. This is very specific. This is pipeline vessels. So heating cables. If you don't know where to go in the NEC, there's an article that deals with heating cables for pipeline vessels, but let's go to the index, okay? And I'll remind you, in the future, I will have a camera that shoots down here, because NFPA does not want to put the index in their link, okay? They say, what's the point? Well, for an educator, it's important. For anybody else, you only don't need the index because you got a search feature. But we're not using a search feature, and you can't use a search feature on an exam, right? All right, so what we're going to do is we're going to go look here. We're going to look for heating cables. So I'm going to go to the index. I've got my code book just like you. And I'm going to go down and look for heating cables. It says C424 for heating cables. All right, but these are unique heating cables, right? So you're thinking, okay, well, is that where I need to be? So this is a great example of, well, okay, so it says heating cables goes on 424. So remember what we said earlier? You would think, okay, I'm just going to go to 424, right? But then you're looking around and going, okay, is it heating cables? But this is pipeline vessels. So is there anything in there for that? So I'm going to look, and that would take trade knowledge, folks. You'd have to know that when we talk about fixed space heating, and then we're talking about heating cables, there are heating cables that are in 424. But you also look at it and go, Alberto, are you just guessing? Do you have your code book? So now we're looking at it and go, okay, well, let me look real quick and see if there's something unique about pipeline vessels. So I want to go look in the code book and I see pipeline. And then all of a sudden I see pipeline. It says fixed electric heating equipment for pipelines and vessels. Okay. Now, while I'm in here, I'm looking and see if I see pipeline, and that's pretty much it. I don't see anything about pipeline. I just see that. And that's sending me somewhere unique. That's sending me to 427 is where that's sending me, to the definitions. Okay. Well, here's another thing you can do. If you get to knowing that something is actually an article and you do your flashcards and you create your flashcards, then you'll know, then you look at this and go, wait a minute, I think this is something in the code. So what could you do? You go to the table of contents. And if I go to the table of contents and I look at that and I go, okay, well, this is going to be under equipment for general use. And you'll notice that 427 says fixed electric heating equipment for pipelines and vessels. So what I can promise you is that no matter what happens for you, okay, you will know that pipelines and vessels, right, is, you know, a specific article in the code. You'll be like, dude, if I see anything on heating about pipelines and vessels, then I know that it's 427. That's why it's so important, folks, to do those flashcards, because then you'll get to know and you'll be able to remember things. And in the 2023 edition, we give you blank, and you can make as many flashcards as you want. And I encourage you to make a flashcard on every article in this code book. Use a table of contents and just make one on every article, every important table. And it's going to be beneficial to you. I promise it will. Okay. So let's get back to the lesson. All right. So we got to go and we got to search this out. So we know we're going to go to 427, and it's not very big. Okay. Not very big. I know, Alberto, you might have got it right. I just wanted to tease you. All right, so now let's go to the code book. And we're going to go to 427. And there you see it right there, fixed electric heating equipment for pipelines. All right? And you've got everything you see here. All right? And of course, you could go down and there's the markings. And remember, this question was about markings. But we're going to use bold scanning because I want to get people familiar with bold scanning again. So here we are. So we know what the scope of 427 is. Okay. It's these heating systems that are used with pipelines and vessels. Remember that, 427. All right. So there's other articles. Here is continuous load. Here's general. Here's use. Here's thermal protection. Has nothing to do with markings. Identification kind of sounds like markings, but it's not. Secure, not indirect contact, expansion and contraction, flexural compatibility, whatever that means, power supply leads, electrical connections, markings. Just that quick, and all of a sudden, my mind or my vision brought me to this 3 inches, because we know that in our question, it's giving everything in inches, right? So it says each factory assembled heating unit shall be legibly marked within 3 inches of the termination end of the non-heating lead with the permanently identified symbol, catalog number, blah, 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 blah. So that's the markings, okay? End of the non-heating lead, okay? So that's our question. So we come back to our question here. It's 3 inches. And there's our reference, 427.20. Okay. Now, many ways to find that. You know, I would say, somebody might say, well, what about if I looked in the index under markings? Was there anything under markings? Well, there's so many marking rules in the code that I doubt there is, but we're going to go look here. Why? Because that's what you should do, is you should go double check. Now that you know the answer, that's how you properly use exam prep questions. This is how you dissect them. So I want to go in the index because you're preparing for an exam, and you look at it and go, okay, let me look under M. real quick and see if by any chance if there is anything for markings and it happens to say anything about pipeline and vessels. It's worth a look. So I'm going to go look under markings, see if there's anything under markings. There is markings. And okay, so none of those. They're really just the general field labeling, manufacturer markings, and all that. So nothing big there that would have helped us. So at least we know that, right? It's part of why we do this, okay? All right. Good job on the questions. Let's go on and go to the next one. All right. Electrical equipment that depends on the blank circulation of air and convection principles for cooling of exposed surfaces shall be installed so that room airflow over such surfaces will not be prevented by walls or by adjacent installed equipment. Okay. What does this sound like to you? If you got this one on an exam, what does this sound like? This sounds to me like it's a general requirement type of question, okay? Kind of like the working spaces and all this kind of stuff. It's talking about electrical equipment in general. Well, what article deals with that? Well, that article is 110. So if we were going to bold scan, we would start at the beginning of 110 and we would work our way through it. And what are we going to be focusing on? We're going to be focusing on things like exposed surfaces, references to air and convection principles, and all those. Those are all airflow. All those are trigger words that we could find. Okay, but since we're doing this, we're going to be looking in the index. I'm going to look under electrical equipment and see what we might have under electrical equipment, just to see. That's how we do it. So I'm going to go in here and look and see here. Electrical. Let's see here. Electrical welder. Discharge. Electrical. Okay. I really don't see anything in here that's going to drive us to that. So I'm like, okay, well, I don't see anything that helps there. Okay, let's look at the question. All right, what else might give us some information? How about exposed surfaces or surfaces, maybe? Okay, so let's see here. Let me look under exposed surfaces. See, it might be something. There you go. I see something under exposed, right? So I see something there. Doesn't necessarily mean that's going to help us anything, but I see something there. So you're thinking, okay, well, and then we go down and we see, okay, let's look at some of these that are here real quickly. Because remember, folks, if you don't know, you don't know. So you've got to use whatever resources you can to try to find the answer, right? So I'm going to look down here and go, okay, let's see here. Yeah, let's see here. I don't really see anything that helps me too much in there, all right? So let's see, what about, let's see here, another part of this question. Now, I think when it's see electrical equipment, this is an application thing. I think 110, but we're trying to see if we can find anything in this that might be helpful in the index. Let's see here. Under surfaces, looks under surfaces, see what we might have. Okay. Now, for me, I would have gone to 110 and started bold scanning. 110 isn't that big, and I know exactly what I'm looking for. But I tell people, look, you spend good money for questions, right? Right? And so when you spend good money for questions, this is how you dissect a question. So when people ask me, Paul, how do you dissect a question? This is how you do it. All right. So let's see here. Oh, Juan says look under heated. Okay. So we'll see Juan. We'll look and see if that helps us any in that one there. So there you go. That's Juan gives that reference right there. So I'm going looking under surfaces real quick just to see. Because I want to see if there's anything under surfaces. Learning, and I'll know that if it's not, then I'm forever done, okay, for that. So let's see, under surfaces. Okay, we've got supports. We've got surfaces non-metallic raceway. We got surfaces exposed, okay. So really nothing else there that's really beneficial to anybody. in that area. Okay. All right. So Juan says look under heating or heated. Okay. So might as well look under heated. See if you see anything under heated. See heating. Let's see now. Let's see. Really nothing really underneath anything of that would be any beneficial to anybody. Okay. So here's one tip, folks. You are not. Okay. All right. Manny says look under equipment. So this is good because if this is a question about general equipment, right? Then we want to look under and see forever if we'll know that as we move forward, we'll know what is under equipment and what is not under equipment. And that'll help us grow. And that's why you dissect these questions. So let's look under equipment and see what we see. All right, I'm looking under equipment. Cooling. Absolutely. Ding, ding, ding. Manny nailed it. So this one here was equipment, and he got the cooling of equipment. Bravo, Manny. So let's go and see. Now, I want to show you how bold scan would work because I would have picked this is because of reading the question. I would have been electrical equipment. This would have been an installation, general requirement. I would have gone to 110 in bold scan before I spent a lot of time. That type of thing, right? But now you'll forever remember that under equipment, and by the way, there's a lot of stuff under equipment. There's, let's see here. Some of it redirects you, but cooling of equipment most certainly gives you a code reference. So very good. If you have equipment that's less than 50 volts, then you have a reference to 720, all types of things, and it sends you all over the place. Okay. All right. So let's go to the NEC. And let's follow Manny's rules here, and let's take us to 110. And why would I have gone to 110? Because these are general requirements for electrical installations. And this just sounded like a general requirement to me. So let's bold scan it really quick. So there's the scope. Important thing about scopes, folks, is make sure you understand the scope before you do anything, because you could be working inside of a specific section or specific article, by the way, that really isn't even germane to what you're doing, right? You might be in 517 for x-ray machines but maybe yours is not a healthcare facility. It's other than, maybe it's an x-ray for like boxes, but yet you go digging in 517 when 517 has nothing to do with x-rays. You know what I'm saying? So again, be careful where you're at and make sure you always read the scope, okay? So, all right, Manny, so we're here, we're approved, not part of the question. Examination, not part of the question. Voltage is not really part of the question. Conductors, not part of the question. Conductor sizes, not part of the question. Integrity of wiring, not part. This is bold scanning, by the way. Not part of it. Deteriorating agents, not a part of it. Mechanical execution of work, not a part of it. Boom. Mounting and cooling of equipment. All right, well, we're not worried about the mounting part. We're worried about the cooling part of it. And here, right away, you see air and convection principles. You remember that from the question. So boom, you already know you're there. So what was the question again? It says electrical equipment that depends on the blank circulation, okay? Natural circulation, okay? So we'll go back to the question, okay? Natural. There's your reference, Manny. Great job. 110.13b. Dude, I can't even speak tonight. You know what I'm saying? All right. Next question. Great job, Manny. All right, next. Multi-conductor flat cable of the blank. So we're worried about a size here or larger. Shall be permitted to employ an external ridge on the grounded conductor. So for identification, it might not be color coded. What it'll have is this multi-conductor flat kind of cable. Okay, we're not talking about UF and NMB. It's not what we're talking about. It's a multi-conductor flat cable. And for those of you that are savvy, know that that's a wiring method, right? And there's something about that. And you're sitting there going, but what are we talking about? Well, we're trying to, is it about the cable? Or is it more about the grounded conductor? Identifying the grounded conductor. Because you remember, folks, we have rules, and we're talking less about the actual cable itself, but we're talking more about what? The grounded conductor within that cable. All right, so two things you can look at. Now, again, so you'll get used to this, but grounded conductor has its own article, and you all should know what that is, especially if you've created your flashcards. And now, since we're talking about identifying a grounded conductor inside of a multi-conductor cable, or in this case, on the outside of it, remember the rules in 200.6 that if it is 6 and smaller, it's white or gray or any color other than green with 3 white or gray stripes. And then when it's 4 gauge and larger, we're able to re-identify it as long as it's not a green, obviously, right? But what about this when it comes to this little ridge? We're still talking about being able to identify the grounded conductor, okay? So a couple ways we could have looked at this in the code. So if we go to the back, let's just dissect it again. We could have looked at multi-conductor flat cable, and we could have looked at grounded conductors, okay? So first thing I'm gonna do, again, the reason we're doing this is to get you familiar with the index. That's the only reason we're following this method. If you already knew the answer on the exam, you just answer it and you move on. What we're doing is showing you how you would dissect a question tonight. And so, and then other people ask me, okay, Paul, that's all great. What do we do when we get about 2 weeks out from the exam? Then that's when you can time yourself. Put your timer on your phone, put 2-minute timer on it, push the timer and work the question and try to work it in 2 minutes, okay? That is not what you do when you're in the middle of a study mode, okay? If you're studying for 90 days, this is how you're gonna dissect the question. This is how you're gonna squeeze every bit out of these questions, okay? And it's also gonna help you learn what is and what is not in the index, okay? So that when you're scanning it, you don't waste as much time, okay? All right, y'all have seen this question on the board here for a while, looking for some help here in the chat, but I'm gonna go and look at so I'm gonna look at multi-conductor flat cable and see if there's anything in the index under that, and then we'll look under grounded conductor. So I'm gonna look here. You got your code book, look with me. And I'm gonna look and see under multi-conductor assembly. Let's see here. I don't see anything else under this. So where else am I gonna look if I'm looking about cables, okay? Then I'm going to be looking under cables. So I'm gonna go back, now I'm gonna go to C. I'm just gonna skip grounded, okay? Because we know we're talking about a grounded conductor. So I'm gonna go back and look at cables. Okay, real quick, let's see if there's anything under cables because we're talking about a cable. So let's see what we got under cables. All right, cables, we have different ones. Let's see here. And what I'm looking for is the multi-conductor flat cable. All right, let's see what I can find here. So I see MC, I see a bunch of different types. Okay, so I do see what's called flat cable assemblies, okay? And that is an FCC product, right? That's not FCC as in the FCC. That's what it is in the code. It uses the acronym FC, or you have, that's the flat cable assembly, or you have flat conductors that are FCC. And I'm looking at those and I'm sitting there going, yep, none of those are really beneficial to me. I could go to flat cable assemblies and see what it says, and we'll probably do that just to learn. But right now, I didn't see anything big that helped me, so now I'm gonna go to grounded conductor. Real quick. And let's see here, under grounded conductor, let's see what we got here. All right, I'm under G. And I'm gonna look under grounded, okay, grounded conductors, and I'm gonna go down. And I'm going to see different systems. Let's see here. Okay, use and identification. Article 200, obviously we're talking about a grounded conductor. The whole question's about a grounded conductor. So I'm going to end up going to Article 200. And the other thing that you got to remember, folks, what is something that I used to teach you? If you know that an article is very light, means it's not a lot of parts in it, it's not a lot of articles in it, then bold scanning is going to be your best friend. Okay, so I'm just going to go to 200 and right away. So let's just go to 200. All right, and 200 is obviously use identification of a grounded conductor. I'm just going to click on it. You're going to see that it is not very big. I'll scroll down for you. Okay, it's not very big. In your code book, 2-3 pages max. Okay, so what we're looking at is we're interested in a multi-conductor flat cable. So look at the scope. Here we go here. And if you already know it's about the identification, okay, then you know to go to 200.6. So now we have to pay special attention because we're looking for the rules for a multi-conductor flat cable. Okay, so here's our sizes. Y'all told you about it earlier. There's your flexible cords. All right, there's your grounded conductor for nominal voltage. Okay, oh, here we go. Grounded conductor for multi-conductor cables. Okay, all right, so let's see here. Boom. Multi-conductor flat cable. That stuck out to me like a sore thumb because that's what we're asking about. Okay, and it says for and larger, you can have external ridges shall be permitted to identify the grounded conductor. So that is a flat multi-conductor cable. And to know which one, because it won't be color coded, it'll all probably just be a gray assembly. To know which one is the grounded conductor, you're permitted to put these ridges on the outside of it, but it's 4 and larger. So let's kind of go back here. So we already know the answer is 4 and larger, and there's our reference, 200.6E. Now, interesting enough, was there anything in FC that would have done this for us? Okay, so let's kind of look at that and say, okay, is there anything in FC? So let's go to the different wiring methods, and let's look at FC. And see if there's anything that would have said anything to us. I doubt it, but I want to look anyway since I'm here. Okay, securing boxes, fittings, none of that stuff's speaking to me. Construction, conductors. All right. So flat cable assembly shall have conductors 10 and larger, but that has nothing to do with the identification. Markings. Okay. Here you go. The grounded conductor shall identify throughout its length by means of a distinctive and durable white or gray marking. Okay, but we're talking about, on this one, we're talking about flat cable assemblies, okay? And so that might be for that, but let's see here. What else do we got? Since I'm here, I want to look under flat conductor cable, FCC. All right, let's look and see what we got under this. See if we have the same. This is a little bit bigger. Okay. Markings. Okay, that's what's marked on it. Okay. All right, this one's interesting because this is probably the more accurate one to be at, flat conductor cable, FCC, rather than the other one, which was flat cable assemblies. No. Flat conductor cable, because it was a multi-conductor flat cable, so flat conductor makes more sense. So I'm just looking to see, so it really wouldn't have been beneficial to us here because this really doesn't address it. So you have to know, right? You have to know that we were talking about the identification of the grounded conductor. These are all great things. Did you know there was even this article in here? All right, so we're just kind of looking down here again. Splices, grounding, I get it. Let's see here. Construction, okay. All right, materials, got it. Got it, okay. Yeah, nothing would have helped us here, okay. So why is that so important? It allowed us to look and see what we're talking about. In our case, you needed to identify that this was a grounded conductor that was in question. And it was much easier because if you're dealing with a grounded conductor, how to re-identify the grounded conductor, anything about it, and it's Article 200, and that's where you go. All right. Good job. Next question. All right. this one says you have three 3/0 XHHW aluminum conductors connected in parallel for a length of 678 feet will have a total resistance of how many ohms? Okay. Well, you've got 3 of them and you've got 3/0. Now, something important about this one is that when you're taking an exam, you're doing maybe an exam question or something like that, and you might think to yourself, what happens if I fluff around it and it's not 100%? Right? If it's not 100%, am I still going to get the question right? You want to choose the best plausible answer. So this is going to be a great one to choose the best plausible answer, okay? So let's look at this and say, okay, what do we got to do? So we know that it's 3/0 aluminum XHHWs, okay? But really, we're focused on the what? We're really focused on the fact that it's aluminum and it's 3/0. That's what we're really focused on. So let's go to the NEC, okay? Oh, wait a minute. I didn't even show you the question. I'm sorry. So here's the question. 3/0 AWG XHHW aluminum conductors connected in parallel for a length of 678 feet will have a total resistance of blank ohms. Okay. So 678 feet total resistance. Okay. All right. Now we can go to the NEC. Sorry about that. Sometimes I get lost in the different forms that I have. All right. So where we're going to go is to chapter 9. We're going to go to table 8. And this is our, no, that's stranding. Sorry about that. Conductor properties right here. So we're going to be working with 3/0 right here, right? And what we need to do, and I need to move down, is I need to go over and I need to find out what it is per 1,000 feet of aluminum. Now let me move this so I can make sure that I follow the right line. So let me go on and highlight this whole line. Okay, so let me go up here. So we're going to be doing this right here. We want the ohms per 1,000 feet. So let me write this down. So this is going to be 0.126. Okay. Everybody with me? All right. So where's my calculator at? Oh, there it is. Okay. So that's per 1,000 feet. So I want to take that 0.126, divide that by 1,000, and that gives me 0.000126 per foot. Okay, so I'm going to take this, and how many feet did we have? I think it was 687 feet. So I'm going to take this times 678 feet. Okay, and that's going to give me 0.085. Okay, so you're saying, okay, but that is the one, but we have 3. We have 3 of these. So what do? We divide that by 3. And that gives me 0.02847, which we're going to round up to 0.0285. Do you see how I did that? We started out with 1,000. We found out what it was by foot. Then we did it for the 600 amount times the 678 feet. And since it was paralleled, we did it divided by 3. And that'll take you back to this tab. And that's where we had 0.02847, which rounds up to 0.0285. Okay, that is just code knowledge. Don't read any more into this question than this. Okay, the XHHW played no role, had nothing to do with it. Okay, so it had nothing to do with the equation or anything. So, hey, what's up, Swartzy? Thanks for joining me. All right. So this is a great question to answer, because you could get a question like this, and it's key. So remember, go to Chapter 9, Table 8, get the resistance for 1,000 feet, divide it by 1,000 to find out what it is per foot, multiply that by the total distance, 678 feet, and then divide that by 3 because you have 3 sets or 3 parallel conductors. And that's how we got the 0.0285. Actually, it was 0.02847, but we are rounding it up to 0.0285 because that matches the questions. Now, can you see where somebody might pick this one? Because that's what we had before we divided it by 3, I believe. Okay, so don't get sucked down that rabbit hole. They're very good if you just take your time. In fact, if this is one of those ones that is daunting to you on your exam, we divided by 3, Manny, because remember the question? It's 3 3/0. When we did the value, it was only for 1 3/0, that resistance for the distance. But now you're dividing it by 3 because it says in the question 3 3/0. See it? 3 3/0. That's why you're dividing by 3. Okay? All right. It's so important to read that question because we did everything on 1 conductor, 1 3/0 for that distance. Once we did that value, then we got to look at how many conductors. So see how that 3 is next to 3/0? Could that not throw you on a freaking exam? Absolutely, it could throw you. Okay? So again, this is just kind of code knowledge stuff, but I don't want you to miss it on an exam. It's not as nearly as complicated as it looks in a question like this. Okay? And if you got it right, kudos to you. All right, next question. Y'all are doing great. All right, this one says let me make sure y'all are viewing it because sometimes I don't know what screen I'm on. Each multi-wire branch circuit shall be provided with a means that will blank disconnect all ungrounded conductors at the point where the branch circuit originates. Oh, Elwood's in the house. I didn't see you, Elwood. Welcome, 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 welcome. All right. So think about this question, folks. Dissect it. First thing you'll notice is that we're talking about a multi-wire branch circuit, and we're talking about disconnecting it. Now, y'all understand the hazards that can be involved if we did not have a disconnect that disconnected all of them. Why? Because if I ran a multi-wire branch circuit and I put it on 1 receptacle and I broke the tab on the neutral, and so the top, I broke the tab on the hot side. If I had 1 conductor on the top and 1 conductor on the bottom, the hot ones, and they're sharing a neutral, if somebody turned off the breaker to one of them, then somebody working on it might think that the whole thing is dead, but it's not, right? So this question is one that you can answer without really doing a lot of work, although we're going to look it up, is that you realize that if I turn one off, then I have to turn the other one off. So obviously, the best answer is that they both have to simultaneously be disconnected, right? But how would you find that in the code? If you didn't know this, and if you're in our Fast Tracks program, I promise you know. But if you weren't, how do we find this? Well, we can go to the index, and one of the things that we can look at is multi-wire branch circuits. So let's look and see what we've got under multi-wire branch circuit. Okay, and you might have to look under branch circuits, but we're going to look under multi-wire because we want to see, because you might get a bunch of questions on an exam about multi-wire. So I want to know, does the index have multi-wire branch circuits in it? Okay, so that's going to help me further down the road to know whether or not I even need to go there for a multi-wire. So let's look at it. So multi-wire branch circuits, absolutely. And what does it say? It says, okay, it says for multi-wire branch circuits, go to 210.7. Okay, so that's a start. We could go there right away. And remember what I said. When you get there, you want to bold scan up and down to make sure it's relevant. And then what are you going to be looking for? You're going to be looking for the triggers, which is also in the answers. You're going to be looking for things like simultaneously, instantly, or whatever that is, automatically, or anything like that. So that's kind of what you're looking for. But for me, first thing I realized at 210.7, okay, so I'm like, okay, I know it's in 210. That's where it talks about multi-wire branch circuits. Okay, oh, that says multiple branch circuits, not necessarily multi-wire branch circuits. Ooh, that's important. So let's keep going. Still in 210, so whoop, whoop. Well, the next one we see is multi-wire branch circuit, and that is in 210.4. Okay, check it. Between 210.7 and 210.4, I can guarantee you they are right next to each other. You can feel very confident at this point that if you're a multi-wire branch circuit, you're going to be going to section 4. But even if you went to dot 7, you're going to be bold scanning up and down to make sure the question, whatever you're looking for, is relevant. But one more thing I want to do. Let's look under branch circuits real quick. In case you didn't look under multi-wired, you said, oh my God, it's a branch circuit. Because the question says branch circuit. So let's see if that would have helped you. So I'm going to go and look at branch circuits real quick. And I'm going to see what also. Now you'll forever remember that multi-wire branch circuit is in the index, right? See how that works? So now I want to see if it happens to be under branch circuits. So I'm in branch circuits. And I'm going to be looking down and see if there's anything under it that says multi-wire branch circuits. Just so I can see. Help me feel good. And let's see here. Multiple. Okay, we have multiple, which is 210.7, which is just, there's multi-wire, 210.4. All right. I'm confident now. You could find it in multiple locations. Hey, what's up, Richard? Thanks for joining me in the chat. Okay. So Swartzy has given us a reference on the screen. There's Swartzy. So again, see, there's many ways that you can find this. So what we're going to do is we're going to go to the NEC and we're going to go to 210.4. But I'm going to show you how you can bold scan if you had gone to multi-wire and you went to multiple branch circuits in 210.7. I'm going to show you how I would have bold scanned it. So I would have gone here, and if I had gone to 210.7, I would have looked at multiple branch circuits. It says still has simultaneously disconnect. So I mean, I could have gotten the answer there, but it doesn't exactly match. So I'm going to bold scan back a few. There's limitations. All right, and let's see here. It's 4. And there's multi-wire branch circuit. Okay, and again, what do we see? All right, we're going to be looking at here. It says, okay, where does it talk about? Where there's A, and here's the disconnecting means, and it says what? Simultaneously again. Okay, so probably could get this answer from multiple locations, but now you know that you could find it in branch circuits. You could have found this in multi-wire branch circuits. Even if you had gone to multiple branch circuits and you would have bold scanned, it would have still gotten you the answer you needed to get. So what did we learn the index? There's many ways that we could find the answer in there. And there's probably more in there. Okay, I don't know, under disconnects or disconnecting means, maybe there's something in there. But I mean, as you start to do this, you'll start to get a little more proficient. Now, again, if you're in the Fast Tracks program, you probably knew that question right away, and you would have gotten you some extra time on an exam, and you would have just blown right through that thing. Sure. All right. But at the end of the day, okay, it's also in disconnecting means. There you go. Boom. Many ways to find it and dissect it in the code. My hope is that you find that you know these things by being in our program, and then you would have spent less than a minute on the thing, and you would have just gained all that extra time for the next question, right? That's my hope. I know, though, not everybody's in my program. So there you go. So there you go, simultaneously, and there it is, 210.4b. Great job. Let's go to another one. All right, receptacle outlets. Oops, my computer over here. Receptacle outlets shall be located on or above the kitchen countertops, but not more than blank above the kitchen countertops. Okay, so as y'all all know, you can have receptacles pop up out of the counter. You can have them, you know, like this kind that pop up like this. Like you can have the tombstones. In the 2023 code, you can no longer have them that serve the countertops. They can't be below the countertop. If they're there, if you put them there to serve the countertop, they have to be above it. Now, they can be above it, but they can only be up so high, right? So what is that? So you know that you could do process of elimination here. You know it's not 12 inches, okay? You're sitting there going, well, I don't remember 16 inches. So maybe you narrow it down to 18 and 20, right? But this one, when you read this, it's receptacle outlets. Now, the first thing that I look at here when I'm doing this is, for me, I'm like, dude, this is a receptacle outlet. This is the holy grail thing that's in 210.52, right? That's what I think of when I see a question. You start asking me about receptacle outlets, and remember, we're not talking about the receptacle, the device. It's the outlet that it mounts into. And you start looking at this and you go, dude, countertops, placement, workspace, the actual placement on a counter and all this kind of stuff. That's a 210.52. You'll get so familiar with that when you study that that's what you'll just gravitate to that. Now, I'm sure we could use the index for this, but I'm going to give you a word of caution here about indexes. Don't let the index turn into a crutch, okay? Index is great, but nothing's going to take the place of knowledge and you just doing this stuff over and over again, going through a fast track program or a structured program. You're going to get familiar with these things and you should be able to answer this right away, okay? Now, years ago, it was 18 inches. It has moved to 20 inches in the last couple cycles. So again, depending on the cycle you're studying on, be careful. So we'll go back to the lesson and now we'll just go to the NEC and we're going to go to that and let's see here. Let's go right here and we're going to go to 210.52, right? Because that's what we said is the holy grail of receptacle outlets. As you see right here, part 3, required outlets. And we're going to 210.52 right here. So now we know it's having to do with what? Kitchens. So we can kind of bold scan our way to kitchens, okay? You know, you got the small appliances, and then you've got boom, 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 and here you go, countertops, right? So there you go, you got the countertops, and then you're talking, there's the wall space requirement, okay? There's an island and peninsular countertop rules. Kind of got funky in the 2023, but it is what it is. Here you go, receptacle outlet location. So it is 210.52 C3-1, 20 inches. Okay, that's our answer. Just that quick. Now, if you had gone to the index, I'm sure you probably could have gone under receptacle outlets, right? And so I'll just do that for craps and giggles. Hopefully you know this one and you just remember the holy grail of receptacle outlet placement is 210.52 and then you can bold scan from there. So if you remember that, that's already going to save you some time. Okay, so let's see here. Let's go look at receptacle outlets real quick, see what we might have. Let's see, let's see here. Let's see, I'm going to look under receptacles. Okay, and let's see here. Is there anything under anything other like receptacle outlets? No. But we're looking under receptacles, and that's not really what we're looking for. But I want to see, okay, well, you see outlets, and outlets are 210.50. And then you see above that it says dwellings where required, 210.52. This is obviously a kitchen, so it's obviously in a dwelling. Okay, so there. Now, why do you say, Paul, why is it obviously a dwelling? Well, dude, in a commercial building, we can put in a break room. We don't have a spacing requirement. We can put them anywhere we want, right? Here, it's talking about a specific spacing allowance, and it says a kitchen, so we have to just go, this has got to be a dwelling unit, okay? So that's where we're at. So 20 inches is our answer, okay? So let's go back here. And again, now we could have processed eliminated this. We could have gotten rid of the 12 and 16, and we would have think, oh, it's 18 or 20, but we know the answer. And there it is, 210.52 C3-1 in the 2023 edition of the National Electrical Code. Just that simple, okay? All right, so let's go to another one. See how we're doing here. Okay. All right, folks, when the optional load calculation is used, okay, now remember for an exam, folks, you always want to assume the standard method, right? Unless they state that you can use the optional method, okay? So if they don't say optional, then assume the standard. Now in this question, they're specifically talking about the optional method. So this is all found, and you all know this is all found in Article 220. So then you need to realize, okay, maybe I need to make a flashcard on this. Remember, our Fast Tracks program allows you to make these flashcards. So maybe I want to do Article 220. Maybe you want to ask for single family dwellings, standard method. It's part 3. Maybe you want to talk about the optional method, 220 part 4. Okay, maybe, so you can make flashcards on freaking just about anything in order to just have your ability to just rattle these things off. So you should be making flashcards in our system on all the articles, all key tables. Those things are just going to be so beneficial. You know, if you don't take my advice, I am telling you, this is your license you're trying to get. This is your life you're trying to make better. Why not use all the tips that I give you? Okay? Are you just some people just too lazy to make flashcards electronically? Dude, they take no time at all to do. I'm just saying. I want you to be successful. So, at the end of the day, it's important to me. All right, so we say it's an optional load calculation. Okay, boom, we know that. Now, if you're in my Fast Track program or if you watched any of our videos, then you know what? Well, you know that when we're dealing with the optional method, okay, then where do we go? 220.82, right? Okay, so let's go into our code book. Of course, you could use the index if you want, but this one I would rather you get familiar with Article 220 and start realizing that the Part 3 is a standard method of calculating. Part 4 is the optional way of calculating, okay? And once you have that, then they're very small, very detailed, but very small, and they're very small parts, but they give a lot of information. It's just going to save you a crap load of time if you get used to that type of thing, okay? Schwartzy, look at him. Schwartzy's throwing these references out on the table. Schwartz is in the house. Okay, let's go to the NEC. Share this one. And we remember we're in 220 and we're going down to, I'm going to bold scan. We're going to go down to the optional method, which is part 4. You see it right here. Here's the optional method. You see it on the screen. Part 4, get used to it. This is the standard method. This is the optional method. Okay, dwelling unit. Okay, the general loads. And then we're looking at heating and air conditioning and all this kind of goody stuff. Okay, so you're saying, okay, where do I want to go? So you're thinking, okay, where's my reference? Where am I going to go? All right, so let's get back up into here. All right, so here it is, right here. Oops. We got 220.82. And the optional method is what? Below calculates used, we're talking about what? Heating. Heating. Let's look at the question real quick. I want to make sure y'all follow the question. Using the optional method, we're talking about the heating load of the dwelling unit that is controlled by 4 thermostats. Okay? 4. Okay? All right. Let's go back to where we're at. Schwartzy was already way ahead of us. Okay, so here we are. And there we're dealing with the feeder. There's the general loads. And there we got the heating. And then what we're looking for is thermostatically controlled, right? So down here, or separately controlled. Thermostatically, each one separately controlled. Well, there it is right there. 40% of the nameplate rating of electric space heating if 4 or more separately controlled units. Okay? So we had 4 separately thermostatically controlled heating units here. So 40% is most certainly the value that we're going to use. Excellent job, Schwartzy. So we'll go back over, boom, boom, and there's your reference right there. Boom, boom, bing, bang, boom. Okay. What'd you say, 80? Well, I already thought you meant 82, so I just gave you benefit of the doubt, Schwartzy. All we did was blast that you gave the wrong reference, but you got the right answer. Okay, you were so quickly on the that type of thing. In fact, does the 80 even exist? Hold on for a second. I'm gonna cut you some slack. Oh, there is an 80. Now, that's just the beginning of it. Okay, good enough. Good enough. I'll cut you some slack. All right, next. All right, folks. What is this one? It says, a blank is a point on the wiring system at which current is taken to supply utilization equipment. Okay, folks, this one is a big one for me because everybody wants to talk about receptacles as outlets. They say this stuff all the time. Hey, I got 2 outlets in the room, right? I got 2 outlets, I got 3 outlets, I got 6 outlets. No, you don't. You have 6 receptacles, which are devices, but they are mounted in a receptacle outlet box. But that outlet box could be a 4-inch square capped off that you actually come out with a whip or something to a piece of equipment or something, right? A piece of utilization equipment. It's still considered an outlet. Why? Because it's the point in the system where you're getting the power to supply the piece of equipment, the utilization equipment. So that is an outlet. Of course, this is a definition. And when you read a question on an exam like this that reads like a definition, then you know it's a definition, okay? So it's an outlet. And again, Article 100. By the way, folks, in the 2023 edition of the National Electrical Code, all of the definitions are now relocated to Article 100, okay? So they're all going to be on Article 100, okay? Y'all are doing great. Next question. All right, let's see here. Receptacle outlets shall be calculated at not less than blank VA for each single or multiple receptacle on one yoke in a non-dwelling location. All right, so this is, and we're asking about the VA. So this is a pretty important one for me as well, because I know that people want to do in a dwelling, they want to come up with the VA value, right? But again, in our situation, this question is asking about a non-dwelling, and you all probably are very familiar with the VA per device. Now, whether it's a single strap or yoke with one receptacle we call a simplex, or a duplex receptacle, which is basically 2 receptacles on one strap, or we could have 3 receptacles, okay, on one strap that mounts on a box. Doesn't matter. Since it's one strap or one yoke, it has one VA value on that one strap. Where do we find this information in the National Electrical Code? Okay, well, this one is different than, let's say, oh, I'm just going to run into 210 and look around for branch circuits. And remember, that was receptacle outlets. That's the actual outlet. This, it's a load calculation. And it's asking me for a VA. So this is important to remember something. 220 is the holy grail, and it's important. Let me come back to me real quick. 220 is the holy grail of calculations. Okay, so you have part 2, which is branch feeder calculations, the individual components of it. You've got part 3, which is for service and feeders, the overall calculation. You've got part 4, which is the optional. But for all of those little nits and picks and little things to do with the calculation, that's going to be in part 2 of 220. That's where you're still going to go to get all. So if it was asking you about a service or something to do with services or feeders to a remote panel or something like that, then you're going to be in part 3 or part 4. But here it's asking about the specific receptacle, okay, and that type of thing. Now, what's interesting about this question is, and I love when I can point out errors kind of in the verbiage, because that's important for us to learn verbiage, right? So let's go to the lesson. Notice how this says receptacle outlets. Okay, it's really the device, the yoke. Okay, so it should say receptacle device shall be calculated and not less than. So I love pointing these out. I don't write these questions, but I love pointing them out when there's terminology, semantics that can be beneficial to all of us. Okay, so what we're going to do is we're going to go into 220. I see a lot of good answers there, and we're going to go to 220. And we're going to be looking at the way it's laid out. And you see here, I don't know if I said feeder. I meant to say it's just branch circuit load calculation. Sorry, feeders are going to be up here in part 3. Okay, so here's your branch circuits, and we'll go to general. It's not really big, okay? But if you didn't know where to go, you can bold scan it, okay? Maximum load, boom, boom, boom. 220.14, other loads. Boo, none of these are dealing with receptacles and the yokes, so you can kind of look pretty quickly. That's nothing to do with it. Receptacle outlets. Now, of course, it's calling it receptacle outlets, so we're going to cut them some slack. Okay, we're going to cut them some slack. But what we want to focus on is this: 180 VA. Now, could you get a question where it talks about that quad thing where you got 4 of them in it? It looks like a 4x4 quad one. But then don't forget that if it is 4 or more, then it's 90 VA per receptacle. Okay? That type of thing. Anyway, I don't know if there's some pictures here. There you go. So see this one right here? So this would be 90 per. But see, these are 2 on strap. So they're 360. Okay? So that's 180 each. So this one's 180. They're all on one strap. There's a duplex, still 180. There's a simplex, still 180. Okay? Makes sense? Beautiful. All right, so it's 180. So we can go back to our question and just go 180. And there's your reference. And a bunch of you got that one right. Did a good job. We're almost done with these questions, folks. So let's do another one here. All right, a 240, 120 volt system. Let me make sure I'm on the right screen. Okay, sorry about that. Just want to make sure I'm there. A 240, 120 volt system that has 9,000 watts on line A and 8,500 watts on line B will have a maximum unbalanced current of blank amps on the neutral. What do you think? Okay, what do you folks think here? What's the difference that you think you have maximum imbalance load, right? So we have the watts. So the one thing we have to look at is that we have watts, but it asks for it in amps. Okay, so the first thing that we're going to do is say, okay, so it's the neutral. So we're going to talk about, since it's 240, so we're going to go 9,000 divided by 240, and that is 37.5. Okay. And then we're going to go 8,500 divided by 240. Okay. And we're doing these first at the 240 volt, but we are talking about the neutrals here. So these looks like they're just 90 watts. So these are small loads here. Okay. So let's see here. Let me go. I'm going to work them both first. So 8,500. Okay. Divided by 240. And that is 35.41. Okay. So now I'm going to look at it and see what my answers, and I'm just showing you how we do this. So I'll take that 37.5 minus 35.41, and I want to show you why that's only 2 amps. So you know that this can't be 240. All right. So let's do this. 9,000 divided by 120 is 75. And 8,500 divided by, let's see here, divided by 120 equals 70. Okay, so the thing about this is the maximum imbalance is the maximum amount from each phase that could be on the actual neutral. So let me example. If 9,000 watts is on A and 8,500 watts is on B, if you have nothing on B, but you have 9,000 on W on A, then the maximum value is going to be what? 75 amps. If you had, and so it really doesn't matter what 8,500 because the 9,000 is going to be higher. Okay. So we want it's the maximum imbalance. So the answer is 75, and that's trade knowledge. Okay. So it's important to kind of look at the question and break it down and dissect it, but we had the wattage, and so that is a total amount on one or the other, okay? Hopefully that makes sense. But we want to use the answers to help guide us, and that was my example of doing that. I'll do it again because people get confused. I'll do it again. So if I didn't know what they were asking here, then I'm saying, okay, it's a 120, 240 volt, but we're trying to find the neutral loads, okay? But to work with these answers, I would have gone, okay, so it's 9,000 divided by 240. So 9,000 divided by 240 is going to be 3750. Okay, so that wouldn't be the answer. So we look at 8,500 divided by 240, and that is 35. Okay, so either one of those wouldn't be the answer for this scenario. So you do each one by the 120, okay, because that is the neutral contribution is the 120. So I do 9,000 divided by 120. That's 75 amps on A, line A. And then on B was 8,500 divided by 120. And that is 70.83 amps. So the maximum imbalance load is going to be from A. Now, granted that those are going to cancel out, but if you ended up having nothing running on B, then you have to go with which one would have provided the maximum unbalanced load. In this case, it would have been line A, and that would have been 75 amps. Okay? Does that make sense? Hopefully that makes sense to you. Okay? All right, but I just showed you two ways to do it to rule it out if you get confused on it. Okay. Let's see here. Let's go to another question. That's a great question. All right, next one. A vertical clearance for a 20 kV, okay, so 20,000 volt feeder that passes over the roof of a building that is accessible to cars but not to trucks. Okay. All right, so this is something that's unique for the 2023. Okay, if you're in the 2020, 2017, a little different. In the 2023, this is a new article, and is Article 235. So I'm going to help you out with that. Okay, so let's go to the index. Let's go to the code, and you're going to see that it is, and I really want to show this one because, again, I don't have my 2023 code book handy tonight. I know. But this was absolutely a new code article right here. Article 235, branch circuit feeders in service over 1,000 volts AC. Okay, so that's where we want to be. So we're going to go here. Now our question was about the feeder. So this is branch circuits. So we would have gone down. Let's see here. So there's that one. And let's go on. Let's keep on going. It's going to jump up pretty quick. See how this jumps from 60s up to 200s, right? But we're looking for what? Okay, so we got feeders, and now we're looking for, okay, all right, well, this talked about over a roof, so it's obviously outdoors, okay, so it's over a roof. So what are we looking for? Let's see here. Continuing to go down. For clearances, we're definitely looking for clearances. Because that's what, oh, there we go, clearances. Right there, all right? So clearances over roadways, walkways, yada, yada, yada. All right, so in our case, it's got vehicle traffic, okay? So let's look at our clearance options here. So we have a bunch of different options here. And let's see here. Roadways, driveways, parking lots, and alleys. Okay. All right. So there we go. Are we more than 22K? No, we're not. So we're going to be under this one. And it looks to me like, did it ask about the vertical clearance for over a rooftop for people to walk over? Okay. So it looks to me like if it's a walkway, then it might be 13.5 is the answer. I'm not sure. Kind of weird the way this question is written, right? So I guess could be argued that it's that one. But let's see here. Let's see if we got anything. Let's see. Okay, well, it looks like, what are we doing here? Okay, that didn't look like that's it. Let's go a little further. Clearances over building. Oh, okay, wait a minute, folks. This is clearances over roadways. It wasn't about the building. Here we go, clearances over building. That makes more sense. So now let's see here. All right, so we are 22 kV or less. So let's see here. Let's see, which one could it be? Over roofs accessible to vehicle, but not trucks. Dude, 13.5. So it looked like it was closer because it's a walkway over a building. It looks like it was more closer to this, but we saw nothing in there. But then we realized, dude, it's clearances over buildings. And we remember that it says that it is vehicles, but not trucks. 13.5. So ultimately it would have been the same answer. 13.5. Let's see what the reference is. 235.361A. Cool. So there, it pays to keep looking, folks. Pays to keep looking. Now, how this is in the 2020, I'm not sure. So I'm going to go look in 2020 for all of you 2020 folks. So when we go down to look at 2020, we're going to be talking about clearances, right? So everything got moved out of that. So what are we talking about? Vertical clearances over roofs for the feeder. All right, let's see here if it's 225. And let's see here if we got clearances. And let's see what we got here. Let's see what we're at. Let's see here. If we got some clearance that we need to, okay. That supports over buildings. Here we go. Clearances over conductors and cables. Let's see here. Clearance above buildings, above roofs. Okay. Final spans. Okay. I don't see it in here. I don't see the table. So let's see here. Okay. Okay. So it's telling me. Let's see. That wasn't good for me. I was using the 2020 clearances. I don't know. I'm in the right one here. We'll have to look at over 1,000 volts. So let's go to over 1,000. See what that would be. That is in 490. And let's see 490. Okay. Let's see what we got in 490. Again, we're looking at the 2020 to kind of look at it and see how the 20, because it was a change for the 2023. So let's see here. Oil field, equipment, isolation, nah. Minimum spacing, we don't need any of that. Let's see. Equipment, clearances, nah, for that. Okay. Just kind of looking down, seeing what we got in here. All right, nothing in there that's been beneficial to us. I'm in the 20. I'm looking in the 2020 now. So let's see here. Let's go back. Let's see here. This would have been. Let's see here. What other clearances? So we had over. So let's go to 225 again, and we're doing over 1,000. Okay. Let's see. Did I get to over? All right. So here is over roadways, and here we got over buildings. So now, so for you that are in the 2020, it's actually in 225.61. And since we're talking about clearances over buildings, let's see if it says the same thing down here. Okay, here you go. Over rooftops, accessible vehicle, but not trucks. And it's 13.5. So you can see what happened. It went from, oh, wait a minute. I wasn't sharing the tab. Damn it, I got to remember to do that. This new system is a little more difficult, folks. So again, bear with me. So here we would have done it. So in 225 is where we would have gone because it was a feeder. And the only difference in here, and notice how it changed. Now it's 235.361. In the 2020, it's 225.61. So they threw a 3 in there. And they put it in the new 235. And in 235, they added both branch, feeder, and services in the 2023 edition. Okay? See how important it is? See how that could have thrown you? If you're studying for an exam and you're using an earlier edition, then it could have really screwed you up because I went searching for it. I knew it was in 225, but in the electronic version, I'm just scrolling through. But think about that, how that could have affected you if you're working out of another cycle and you're trying to take an exam. That could screw you. But don't panic, you'll get it. But it's the same. Now, probably in the index, it would have been the same thing for feeders. I'm sure under feeders, there was probably something. Let's look real quick. That way we can finish this one out. We'll look under feeders, and we'll look at over 1,000 in clearance and see if there's anything under feeders. We could have done that right away. Now I am in the 2020 in this one, so we should be able to do it. So let's look under feeders. Here's feeders, and I'm looking at feeders, and we look and see if we've got anything for that. that we might need to look at here. So let's see here, feeders. And we have outside. So outside branch circuit and feeders. Okay, so that's what 225 is all about, right? So we probably would go there because you know it's outside because it's over a building. So that's very specific. So I'm going to go to outside. It sends me to outside. So I'm going to go to outside. Again, remember this index. Get used to it. Okay, it's not the holy grail, but hey, it might help you. So outside branch circuit feeder 225, and then I'm looking for clearances. All right, so let's see here. You go down a little outdoors. Over 1,000 volts. It says go to 225 part 3. So let's see how accurate that would have been. Let's go to the end over here, and let's see what we got here. So we'll go here in the 2020, and it says to go to part 3. So let's see how accurate this is, because then we could bold scan, right? Well, there you go. Part 3. And then you would have bold scanned, and you would have looked at bold scan. That's not what it's asking. Boom, boom, boom. You would have gone down. Inspection. No, I don't care about that. And clearances, roadways. You would have said, wait a minute. It's not. It's over a building, not a roadway. Boom. Clearances over building. Wham, bam. Thank you, ma'am. And then it gives you a reference to the table right here. And there you go. And you would have found it, and you would have gone right there. Kimosabi. Done. So you can find it in the index. Okay. Sweet. Next question. All right. Last question for the night, folks. I think y'all did wonderful. So let's look at it here. On a oh god, we might have to do another one. We might have to do one more because this is a question that Schwartzy's probably already answered the daggone thing. All right. So let's read it here. It says on a 4-wire delta connected system where the midpoint of one phase winding is grounded, it's the midpoint, only the conductor or bus bar having the higher phase voltage to ground shall be durably and permanently marked by an outer finish that is blank in color or by other effective means. Okay? Well, interesting thing about that is you all know that one right away, right? Orange. But did you know that if you don't use colors, let's say you're using all black insulated conductors, did you know that you could actually put labels on it, tags on it, other markings on it that are okay to the AHJ, and they would be okay? If you don't use colored conductors, then you don't have to make it orange, but you got to identify it by a means that's acceptable to the AHJ, okay? I think in today, we'd make it orange and we just go on our way. So that's the delta high leg, 208 volts to ground, and that's how we would identify it with orange, okay? Now, you're probably gonna say to yourself, okay, I get it, Paul, but where is that in the code? Well, remember, folks, this sounds very much like a general electrical requirement, doesn't it? And where did we say go for general electrical requirement stuff? I'm betting that this is in 110. I am betting that's where it's gonna be. But if we went to the index, what are we looking for? All right, so if we were going to go to the index, and again, we all know the answer to this one, but since this one's probably going to be the last one, let's do our due diligence, folks. And let's see, where would I find it if you just happen to sit yourself on the exam and you're just totally clueless? You're like drawing a blank, okay? I promise you're not in a fast track program if you're drawing a blank on this one. I can almost promise you. But if you were, where would I go in the index? Okay, well, if I'm looking at this question, I might say, okay, well, let's see here. Let's say maybe it is maybe it's a delta. Maybe it's a delta connected system. So let's look and see if there's anything under delta. Okay, let's just see if we can use the index. You try it too. Sometimes this can be a game. See if you can find it. All right, so I'm going to look and see if there's anything under in the index for delta. I doubt it, but we're going to look. Well, there is delta. Whoa, holy smack, daddy. There is some information about the delta. Oh, dude, guess what? It says identifying the high leg, and it sends you right to 110.15, which corresponds with my thinking because it's a general requirement. It's an identification. It's a marking requirement. Dude, but it's in there. Dude, the index can be a lifesaver, but just don't let it be your crutch, okay? But there you go, 110.14. We're definitely going to go there and look and see, excuse me, 110.15. We're going to go there and see what that says. Remember, 110 general requirements, folks. 110 general electrical requirements. This has sounded very much like a general question. Again, hitting the scope, okay? Looking at everything, just kind of bold scanning it down. Voltages, conductors, no. Integrity, no. Deteriorating agents, not quite. There, we know what we're looking for. We know what our triggers are. Mounting and cooling, we saw that before. Connections, nope. Keep on getting it. Boom. High leg markings. This is verbatim, okay? And we automatically, of all the colors, we see orange sticking out to us. And I don't know if there's a picture. There you go. So B, there you go. There's the delta high leg vectorially between this point. Vectorially, that is 208 volts, okay? From this phase to this phase, okay? From here to here, it's 240. From here to here, it's 240. From here to here, it's 208, okay? It is called, we call that vectorially. Okay, it's going to give a triangle there. That's basically, easy way to think of this is the path goes 240 and then it starts to go the other direction. So you went up to 240, then it starts dropping down. That's just what we call vectorially. And it drops back down because you're not using two full windings. You're using one winding and a half a winding, and how they're situated, then that's going, and their degrees that are off, vectorially, that's how you get the 208. Okay. All right. Anyway, we'll come back to the question and we will do orange. Boom. Y'all nailed that one. Easy peasy. Y'all want one more? You want one more? Somebody give me a hell yeah, and we'll give you one more. If you're done for the night, if you're burnt, you're spent. If you're burnt, you're spent. I get it. We won't do any more. But if you want one more, we don't know what it's going to be. But if you want one more, I'll give you one more. All right, Manny says, let's do this, okay? Manny gave me a hell yeah. That's what I asked for. And he's in the Fast Tracks program, so he knows that I like very much specifically to give me what I asked for, right? Okay? And Swartzy gave me a howl because he just refuses to say hell. Again, bless his heart. All right, so let's go and look at another one. All right. An area at a motor fuel dispensing facility within 18 inches of finished grade and 20 feet from an outdoor gas pump is a blank location. Is it a Class 1 Division 1? Is it a Class 1 Division 2? Is it a Class 2 Division 1? Is it a Class 2 Division 2? Okay, great question to get on an exam, folks, right? Oh, you're going to blame it on the fingers, Swartzy? I think it is just you're too nice of a guy. You didn't even want to say hell. I understand it. I understand it. You're too sweet. I get it. All right, guys, where do you go here? All right, first thing, trigger. What is it? Well, we know that it's talking about what? Motor fuel dispensing facility. Well, if you did your flashcards, you know that there's an article that deals with that, right? But we can go to the back of the index. If you're sitting there going, Jesus, I don't know. Now, what you do is what? You know, this is what Jay likes to do. You know that if you know enough to know that there's an article on that, then you could go to the front index. So I could go to, the front table of contents, and I can go to the front table and I can look and go, okay, well, I already know that what unit it's going to be. It's going to be in chapter 5. So you start going down and you go, wait a minute. Boom, 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 boom. There we go. Motor fuel dispensing facilities. Okay, it's on page 114, and it is Article 514. So you could have done it that way. Or you could say, oh, man, okay, so it's motor fuel dispensing facility. Okay, gas pump. I get it. All right, and so I need to go to the back. Okay, so I want to go to the index, and I'm going to go to motor fuel dispensing. So that seems like that would be the most logical choice. So I'm going to go to Mule. Boom. There's a piece in here on motor fuel dispensing. And now I'm going down, and I'm looking at it and going, okay. Well, it says classification of location. It's not the second one down, folks. Second one down, and that's what we're asking. What is the classification of this area? Is it a Class 1, Class 2? Is it Division 1, Division 2? So boom, I'm going to go to 514.3. Wham, bam, thank you, ma'am. So that's where I want to go. Now, before I do that real quick, I want to talk about something. When it comes to classified locations, class 1, class 2, class 3, division 1, division 2, a couple things to remember. A division 1 means that the condition is there at all times. Okay? It's always there. The vapors, the fumes, everything is there. A division 2 is only there under rupture or an accident, or if certain types of things are stored in a certain area, then it might elevate it to this division 2. If it is an area where the possibility of always having the gases, vapors, and things like that in a class 1, then that would be a division 1. Now, class 2 is combustible dust, and it's the same concept. If it's always present, then it's going to be a division 1. If it's only there because of storing it there or a potential rupture of the system and exposing it that way, then it would be a division 2. Does that make sense? One of the nights in my Fast Tracks Wednesday night sessions, I'm going to go over with my students hazardous classified locations, and so they have a better understanding of that, because every now and then you'll get 1 or 2 on an exam. So we're going to do that one night as well. So if you're not a member of our Fast Tracks program, if you're not a Fast Tracks Black or Plus member, or if you're a subscriber on Fast Tracks Tube, then you can join us on Wednesday nights. The budget course, you can't join us, okay? But if you're a member of Black or Plus, you can join us. The link is in your console, okay? We're no longer doing the live streams on YouTube, okay? All right, it's back to private, so you get that one-on-one time with me every Wednesday night. What do you think about that, Swartzy? He's still jacked about that, I'm sure. All right, so let's go back to the question here. All right, let me get us back to the lesson. All right, so whatever we need to know, so we've already identified it is Article 514, and we already know we're going to 3 because we're looking at classifications. So let's go on and go to 514. We already did all that work. And if you were making your flashcards, then you would have known right off the bat 514, and I probably would have gone there right away because you could have bold scanned it very quickly to get to a question. And the question is talking about what? The location of wherever that fuel dispenser is. What is the classification of the area around it? So let's go to 514. So here we are. And I want to show you it's not that big. So it's not that intimidating. By the way, you see these little illustrations right here, right? Okay. So anyway, I want to go down. We're going to go down. I got the hiccups for some reason. I want to show you that it's not really big. So you could have look at only 16 sections in here. So dude, you could have, really bold scanned it. You'd have probably found it. All right, so let's go back up here where we were at. So we want to get to 3 first because that's where we needed to be. Okay, so here we go. So we're at 514.3. Okay, now what are we talking about? We're talking about A? No, we're not talking about unclassified. We're talking about B, classified locations. That's what we're talking about. All right, now B1, it states right here, it says shall be applied where class 1 liquids are stored, handled, or dispensed. Okay, so that's the class 1 location, right? So now what we've got to do is go down to this table. So we already know that it's a class 1. So that's the first thing, folks, that you should have looked at this exam. When you looked at this question, your mind should have been, okay, let me show you how we would have done this. First thing you would have done is you realize this is dealing with fuel. It's not dealing with combustible dust. So you would have immediately ignored these 2. Now you had a 50-50 chance, 50-50, okay, to get this right. And those are better odds than guessing at 4, that's 25%. So you at least narrowed it down. So always want to narrow down your odds there, okay? All right, let's get back to the tab. So now what are we talking about? So we're talking about the fuel dispensing, okay? So there you go. Fuel dispensing, and you're sitting there, okay. Well, let me see if I can't. I hate how this thing is doing here because it's not letting me, show you everything. So that kind of sucks. Okay. So we're talking about from finished grade, and we're talking about the gas pump dispenser itself. Okay, not the tank. Okay, that's a remote pump. Let's see, overhead type. Did it say anything about the overhead type in it? No. Okay, dispensing device, except for overhead. So here we are. So here's the dispenser, okay? All right, so this is the one right here. So I want to make sure that I carry this out so we know. So here's the 18 inches right here. So you see the 18 inches of that right there. I'm sorry how this is doing this, folks. It's a problem with the screen. So let me go back so we can make sure we're in the same area now. So let's see where we're at. So there's our select. God dang it. It's going to drive me crazy, Swartzy. Ugh. Do I make this smaller? That might help. All right, so there we go. So we got this here. All right. So there's within 18 inches of the dispenser. Okay, and that's what the question was. 18 inches of finished. All right. There's the dispenser. And there's everything you got there. Extension of the class. So the class extends out. All right. And then we've got, since it's outdoor dispenser, it's not indoor dispenser. So we look at the outdoor. And here's what it says. It says 18 inches above grade. So that's the first one that says anything about the grade above grade. Extending 20 feet horizontally in all directions from the dispenser. All right. So there we go. So we're looking at here, we've got division. There's the division, right? So we pretty much know what? Our answer. God, that drives me crazy. Let's go back here to the question. All right, so it said it was division 2, but it was in a class 1. We've eliminated these. There you go. It's class 1, division 2. And sorry about the screen thing. You know what? It's kind of funky, okay? Yeah, link. Swartzy, you said that right. If you're anybody out there is familiar with link, it can drive you crazy. The way you have to scope back and forth and move, you know. I love it. Don't get me wrong. I love it. But it can literally sometimes drive me crazy, right? But it's all there. So that was using the table, okay? And we got to verify our code reference. There you go. 514.3b1, okay? So there you go, folks. That's your reference, okay? So, you know what? Great night of some code. Talked about dissecting a question. We talked about how you should take your time analyzing the question. All those things are going to make you much better. If anybody's getting ready to take their exam soon, you know, really make sure that you get your money's worth out of your questions, dissecting them. You'll learn what's in the index and what's not. Don't let it be your crutch. If you're in the Fast Tracks program, you're going to answer a lot of these things without even having to look it up. Okay. But other than that, that's a little bit of exam prep is going to make everybody a little bit better. So hopefully you got something out of the exam prep tonight. An impromptu exam prep. I didn't even tell anybody I was going to do it. I just did it. So again, if you're interested in our Fast Tracks program to get access to the questions like these, and there's hundreds and hundreds and hundreds of them, not to mention our competency reviews that I grade for you. And if you want to join us on Wednesday nights, then make sure you subscribe to Fast Tracks Tube, and then you can come. Or if you're trying to study for an electrical exam, don't buy books with code questions. Don't buy DVDs. Don't think that videos are the way to go. The way to go is to get a structured program that forces you to read it, because reading comprehension is the #1 thing that causes people more problems on an exam. If you've got to read something multiple times and you have reading comprehension problems, that means you have a hard time focusing. Hey, I know. You know how I know? Because I do that myself. I have attention deficit disorder. I've always had it. My mind is racing 1,000,000 miles a minute. I'm trying to think ahead of the question. It's so easy to screw up. I'm just like you. I'm an electrician who just loves the National Electrical Code. Again, I did my years. I got the scars and cuts and scrapes. I ain't 20, I ain't 30, I ain't even 40 years old anymore. So I wanted to transition to be able to teach you folks to understand the code a little bit better. I'm actually excited for 2024 because the new studio where we're going to be able to have a wall and show you a bunch of electrical stuff, a bunch of demos, I'm excited about that. I'll get my hands dirty again. Okay. So anyway, folks, I appreciate you all. Also, don't forget to listen Sunday evening. And I think I said to the Fast Track students, I think I said 7 p.m. Central Time. Sparky Mafia, the podcast with my special guest, Angry, is going to be at 6 p.m. Central Time. I have no idea why I said 7 the other day. Oh, also, hey, if you want to get a bunch of great code questions, Swartzy's told you right here, guys, do me a favor. Look, I create these resources for you, folks. If you go over to thesparkyhub.com and join that, it's free. Swartzy posts a lot of questions in there to test you. They're free. He does this because he wants to help you become better. Also, if you want to chat, go to our fasttrackschat.com, right? Also, you can get to all of this on our website, folks. You don't have to remember all that stuff. I'll show you how you do it, right? So let me do this real quick. I'm going to get you and show you exactly how you do it. Here, hold on. I'm going to show you perfectly how you get to everything. And you won't have to remember anything. So I'm going to share this screen. Okay, so let me go there and I will share it for you. Right here. So this is our website, folks, right? All you got to do is if you want to get to the Fast Tracks chat, which is a cool chat platform, or you want to get to the Sparky Hub, all you got to do is go to our website and hover over this link. See this? Fast Tracks chat. And here is the Sparky Hub. I'll click on the chat. So here's the chat. You register. If you're already a Fast Tracks customer or you've subscribed to our fasttracksystem.com website, then you use the same login information. You can log in straight away. But if you want to log in, I will go on and log in. And here you go. Look at here, daily code questions, right? It even has notified me that what's going on in here. So let me get rid of Schwartzy's comment there so you can actually see more of what's going on here. All right, so this is a neat forum, and we create it for you folks. So if you go to the chat forum, if you want to get me or Swartzy to come and answer a question or something, then you can go over here and see where this says contact an admin. If you click this, if we're online, we'll come to the room for you, okay? But at any rate, this is a cool feature. And here you see Dustin and Swartzy posting code questions and answering code questions. And, you know, Mike's always posting questions in here. Maybe you just want to chat. Here you go. Happy weekend, everyone. I'm going to say it back to Michael. I'm going to say, let me go back here real quick. I'm going to say, happy weekend. There you go. So folks, you won't ever be belittled here. You won't ever be talked down to here on these forums. These are there for you. I tried to give you as many resources as I can. We're always here to answer your questions and these resources. So one of the other ones, okay, is let me take you back. And let's see here. I'll take you back to the chat to the website, and I'm going to show you the Sparky Hub because the Sparky Hub is amazing as well, and Michael spends a lot of time over there as well. So here we are in the Sparky Hub. Okay, you're at our website, fasttracksystem.com, and you go down here and you click Sparky Hub. You also can get there by going to www.thesparkyhub.com. So when you get over here, you see you have a bunch of forums. Right? See all these forums? Now, when you log in, you register for an account. Doesn't cost you anything. It's free. When you log in, you'll have a neat little chat feature up here that you can post something to everybody that's on the website. If you want, you can say, hello, everyone. All right? You can do that. Hold on here. Let me show everyone if I can type right. And then you hit it. Boom. There you go. See? It'll say, hello, everyone. The other thing, look, Swartzy just logged in right there. So the other thing that's neat is anytime we post something in the forum, you can scroll down, it'll show you what he's posted, and you can go right to the discussion, right? So here you see a forum that's only available to fast track students. So if you're a fast track student, you got to request to get access to this, but only after you register an account, right? But here's the general electrical forum. Boom. Look at all these questions that have been posted. Look at that. Okay, there's a lot of topics in here. Look at all the questions you can test your skills, right? It just goes on for page after page, that type of thing. Okay, you can post questions in here. If you've got a question you want to go, here's the Fast Tracks Live. You can click this, and if you want to ask a question on a session, so here's a question that was posted by, that I posted, and let's see here, Oscar did a follow-up here. Hi, Paul, this is Oscar. Where can I see when my annual subscription will expire to be a part of the Wednesday night Zoom classes? If you can't log into your Fast Tracks console, if you can't get into your course, then it's probably expired, okay? Because it's in the console. The link is in the console. Whether we've already purged you or not or whatnot, you will know if you can't get into your Fast Tracks course, then you've expired. It's been over a year, okay? So I could answer him that way, but we'll leave it at that. All right, so let's see. Let me see if I can come back to me real quick, and we will end this thing up for tonight. So there, you've got so many resources for you. Use them. They're free. We pay for it on our servers for you to learn the National Electrical Code and to ask us questions and to interact. Again, I can't stand the social media. So what I did was I created my own platforms for people to be able to interact, and you don't have to worry about being belittled. You know what? If you're blocked on those other platforms because I jumped on you for some reason, hey, you're free to come here until you start crap. If you start crap, then I'll block you from all of my servers. You don't want to do that, but you want to. Why would you want to do that? We're a family. Everybody wants to learn together. You know what I'm saying? So at the end of the day, it's just great, okay? So now, Elwood says, what's the app? We have a mobile app. Elwood, you haven't downloaded the mobile app yet? Really? As long as you've been watching, you have not done the mobile app yet. Wow. Okay. Well, here's what we're going to do. I'm going to show you what that is real quickly. Where to get the mobile app for your phone. You ready? Okay. Let's go to the lesson here. Here we go. You're over on our website, fasttracksystem.com. Go all the way over here where it says mobile app, right here. Click on mobile app. If you're on your phone, you go here and you click on this link right here. If you're on your desktop, then you just scan this QR code. And that will pop something on your phone, and it's going to ask you, do you want to put it on your phone? The answer is yes. You know why? Because the only thing we're putting on your phone is a quick button that you click. Just a link. That's it. With our logo. That's it. It'll also ask you, do you want to get notifications? Yes, you want to get notifications because you know we might send you updates. We might send a notice out that says that, we might send you different things. So you want to make sure you get them. We promise you, you will not get spammed. That is not what we're all about. Okay? So that's how you get the mobile app. Now, there's another way you can get the mobile app. You can just go to www.necchat.com. necchat.com, and you can do the same thing there. Go there on your phone. You got a button. You just click it. It'll download and load onto your phone. Remember, we're not doing anything from the App Store, Google Apps or Apple Play Store. We're not doing that because if you haven't followed me long enough to realize I literally hate when people put things on my phone, okay? I hate it. So that's why we shifted to the PWA style app. It's in the cloud. All we want to put is a quick link on your phone and you click it, boom, right? It's a beautiful thing. There's a lot of calculators on there. There's a lot of resources on there. You can read our blogs on there. You can even go and log into your Fast Tracks course through the link on there. It just takes you to the portal. So much, and it's free. It doesn't cost you anything, folks. So the end of the day, I'm giving you the tools. Whether you use them or not, that's totally up to you. All right, folks. I appreciate you all. Hopefully you got something out of tonight. Until next time, stay safe. You never know when you're going to catch us, but remember, go to Fast Tracks Tube or the SparkyMafia.com to listen to Sparky Mafia podcast on Sunday nights at 6 p.m. You can even chat with us. Schwartzy will tell you all about how to do that. Till next time, folks, stay safe. God bless.